is Anna Tetzlaff. I'm an undergraduate at Central Michigan University, and my research is about simulating the beam dynamics of the SECAR Recoil Mass Separator using Dynac. SECAR is the separator for capture reactions. It is a facility at Michigan State University, and we're hoping to use it for a cobalt-56 beam for an experiment about the neutrino P process. However, before we use the facility, we are hoping to try and optimize our experiment before we ever get there. And to do that, we want to simulate the beam dynamics of SECAR so that we can find the correct settings for elements along the beam line before we ever even get to the facility. So to simulate SECAR, we'll be using Dynac, which is a multi-particle beam simulation code. Dynac allows the user to set the settings of the beam, such as the initial number of particles or the energy, as well as set the settings for the magnetic and electric elements along the beam line, such as setting the electric field for a quadrupole. Additionally, Dynac allows us to produce plots of the beam at any point along the beam line. That way we can look at what is happening to the beam and try to fix it. Here I have the layout of the SECAR facility taken from the SECAR design paper from 2018. As you can see, our beam will be passing through all of these different elements as it follows along the beam line until it reaches the detectors at the end. Initially, our beam will be coming from another part of the Michigan State facility, RIA 3. It'll then hit the target here and go through all these different elements. The elements labeled with Q are quadrupoles, with B are dipoles, hex is for hexapoles, WF is for the Wien filters, and FP is for the focal planes, where we will actually be looking at the beam. Focal plane 1 is where we will be looking for the rest of this presentation. When it comes to simulating SECAR, we want to see if we can recreate a real experiment. So over here on the right, I have an actual image of a beam taken at focal plane 1. Here we have the center of the beam line, and then here is the beam itself. Now this is a little off center, but we just want to see if we can recreate this using the settings of the beam elements that were used for this actual experiment. So if we take those settings and put them into our Dynac simulation, we want to see if we can actually recreate it. And if not, go back, figure out what's wrong with our simulation, what's causing it to be not accurate. When it comes to producing an accurate simulation and optimizing our own experiment, we're going to be looking at graphs like these, which are what Dynac produces. The set of graphs on the left are from an earlier stage in our optimization, while the four on the right are from a later stage. Both are taken at focal plane 1. So for the graphs, XP is the particle angle in X, and X is the particle position in X. The same follows for YP and Y. In the graphs on the left, we can see a few things that we don't want. So we can see that for the X, it is a bit off-center and a little spread out. Then for the YP by Y graph, you can see it is very, very spread out, which we do not want. The Y and X graph is the same kind of graph that we saw on the previous slide, so we want them to look about the same. However, this graph is a bit off-center to the right. Additionally, it's larger than what we want. For the newer graphs on the right, we can see that the XP by X graph is a lot more centered and a lot more circular, which is what we're looking for. Additionally, the YP by Y graph, while it is still a bit spread out in the Y position, it is a lot smaller. Then looking at the Y by X graph, it is a bit more to the left like we want. And also you'll see that it is smaller than the YX graph on the left by noting the scales of the graph. So this is my research, and I want to thank you all for your time.